So chapter 9 gets us into our next type of function. So we've talked about linear functions, graphing linear functions. We even talked a little bit about absolute value functions. Those were those V's that we graphed a while back. Now we're going to get into quadratic functions. Excuse me. And we have to remember what a quadratic function would look like. Remember, functions map inputs to outputs, map x's to y's, domains to ranges, right? So a function is going to need to have x and y both in the equation. And we have to think about what quadratic means. No, I know quad means 4, but it doesn't have anything to do with 4 of anything. So what we're going to talk about today is how to graph a quadratic function, and at least in a general sense, where we're going to pick out some x's and y's and do a t-chart and that kind of thing. So graphing those quadratic functions that are going to look like this right here. Okay, so y and x are both in the equation. What makes it a quadratic is that term right there. Remember that quadratics are degree 2. Quadratic expressions are polynomials whose degree is 2, which means that the biggest exponent that you'll see is a 2, pretty much, right? So the degree is 2 here because it has an x squared term. So a quadratic function example of that is this guy right here, y equals ax squared plus bx plus c. Now a, b, and c you're going to see used a lot. So get used to the fact that a is the coefficient on the quadratic term, so that's x squared. B is the coefficient on the linear term, or the x to the first, and c is what we use for the constant. Okay? You'll see a, b, and c used a lot with quadratics. Now, quadratic functions have a parent function, which is y equals x squared. We talked a little bit about parent functions when we did absolute value functions, but a parent function is just the simplest function out there of that form. And so y equals x squared is the simplest because there are no coefficients, there are no constants, there's nothing else around the x squared except it's just x squared. Okay? And it has a graph. And when we are going to start talking about graphing our quadratic functions, we're going to get an idea of what it looks like by comparing our quadratic function to the parent function. Okay? And so again, you see the standard form of a quadratic function is that right there. Y equals ax squared plus bx plus c. And again, you have to remember where a, b, and c are, where to find them. Okay, so more vocabulary. A parabola. A parabola is the shape that you get when you graph a quadratic function. It's a U shape. It's a U. Absolute value functions make V's, nice hard-cornered V's, where linear functions make lines. Quadratic functions make parabolas. They're U's. So like this. And this is the graph of your parent function, y equals x squared. Right? So look at this. What are some things that you notice? Okay, hopefully you notice that the U turns at a particular point, right? There's here a lowest point. Sometimes there can be a highest point, but it turns back up, right? Because it's a U. The other thing I hope you notice is that it's symmetrical. If you look on the right-hand side, it looks exactly like it does on the right-hand side. If you look on the left-hand side, it looks the same as it does on the right-hand side. And we're going to use that idea of symmetry to help us graph as well. Okay? Speaking of symmetry, because that's true, because these U's are symmetrical, there's something called the axis of symmetry, and it's the line that divides a parabola into 2 matching halves. And the axis of symmetry will always go through the vertex. And you see there the vertex is the highest or lowest point on a parabola. There's going to be a highest point on some parabolas. There's going to be a lowest point on some parabolas, and that's going to be the vertex. The vertex gives us quite a bit of information. All right, and the axis of symmetry will always be drawn through that vertex. Now, because there's a highest point and a lowest point, there is going to be a minimum value for that function and a maximum value for some functions. The minimum and the maximum values, the way you find values is to find out what y equals. right? If I want to know what the value of a function is for a particular input, then I would put that into the function and find out what y is. And so it's going to be the y coordinate of the vertex. Whether it's a minimum or a maximum, it will always be the y coordinate of the vertex. Okay? Because as you saw, the vertex is always going to be where the graph makes a turn. So here, this particular quadratic function has a minimum value of 0. Okay? All right. So we can get a little bit of an idea of what a parabola is going to look like before we even start to graph it. And that will help us in graphing. Okay, we need to have some idea of where we're trying to go with this thing. And first and foremost, parabolas can open up or they can open down. Your vertex being here, your vertex or being here. So again, your vertex can be the lowest or it can be the highest, like it is here. Okay? Now, what dictates whether a parabola is going to open up or open down is that value of a. Remember, a is the coefficient on your quadratic term or your x squared term. If a is positive, then the parabola is going to open up. If a is negative, then the parabola is going to open down. And I think that makes enough sense. Generally speaking, positive means you're going up, negative means you're going down. So here in these two examples, y equals x squared minus 2x minus 3, this parabola will open up. And in the other example, y equals negative 2x squared minus x plus 2 will open down. And again, it's because of the signs on a. Okay, so then we'll have some idea of whether it's going to open up or open down. How wide or thin a parabola is, right? U's can be really, really wide or really, really thin. Also is determined by a, that coefficient on the x squared term. Okay? If the absolute value, right, if the absolute value of a is bigger than 1, then the parabola is thinner, right? In other words, the bigger a is, the bigger absolute value of a is, the thinner the parabola gets. And the smaller a, the absolute value of a gets, the wider the parabola gets, which is sort of counterintuitive. You would think that if a were bigger, then the parabola would be wider, but it's not. It's the opposite. The bigger the a, the thinner the parabola. The smaller the a, the wider the parabola. And sometimes your a's are fractions. So how can a be less than 1? If it's a decimal or a fraction, and then it starts to really get wide. Okay? All right? And then shifts. Okay? If c is positive, the parabola shifts up. If c is negative, the parabola shifts down. Okay, now where's c? C, again, is that constant, ax squared plus bx plus c. It's always that number by itself. It's the constant. So in these two examples, y equals x squared minus 4, then again, compared to the parent function, this parabola is going to shift down. In other words, the vertex will shift down from 0, 0. That's where it is for the parent function. Here, this parabola is going to shift up. So it should be higher than 0, 0. All right? Okay, I'm going to back up for a second because we're missing the examples for the wide or the thin. I thought we were. So your two examples for the wide or the thin, the first one's y equals 4x squared plus 8x minus 3. If we were to compare this to y equals x squared, would this parabola be wider or thinner? Well, hopefully you're saying thinner. Because again, the bigger a gets, the thinner the parabola gets. This guy, and here's a, negative 1/2. 1/2 is less than 1, right? It's a fraction, so this guy is going to be wider than the parent function. Okay? All right. Let's get back to our conversation here. So we have some ideas on whether a parabola is going to open up or down, if it's going to be wide or thin, if it's going to if the vertex is going to shift around. And so we can get some idea of where and what this thing's going to look like. Now, how to graph it. There are some steps here, and it's a bit of a process. Okay? And hopefully at some point we can simplify this down, but for right now we've got to get into the process. So step one, we've got to find the vertex. We want to find out where the vertex is so we can draw the axis of symmetry and we can start to create this symmetrical U. Well, the way we find the x-coordinate for the vertex is this little formula here. It's opposite b, and generally speaking, that's how I write this, opposite b over 2a. You're going to see this opposite b over 2a in more than one place when talking about quadratics. We'll bring that back up later. Okay, but that's how you find the x-coordinate for the vertex. To find the y-coordinate of the vertex, just plug in x. And then you'll have the point for the vertex. Right? Once you have the vertex, we're going to graph it. And then we know that axis of symmetry goes through it, which is going to be a vertical line. Because right now our parabolas are just opening up or down. Then we're going to do a bit of a t-chart method, right? We're going to pick two x values, two x's. It's not 2 points. We're going to pick two x's either to the right or the left of the vertex. Plug those x's in, find the y's that go with them, and then we'll have 2 more points on that graph, and then we can mirror that on the other side because of the other side of the axis of symmetry, because we know they're going to be symmetrical. And then we connect the dots in a parabolic manner, which just means we draw our U. Okay? So there are some steps here. Let's go through some. See if we can't make this make sense. So first and foremost, we want to talk about, and I'm going to put in here maximum or minimums as well. Look at this quadratic function. This function I know is going to open up. And it's because a is positive. Now, I want to go find the vertex. And I have that formula to use, opposite b over 2a. The b, this is b, this is a, this is c, is 4. So opposite of 4 is negative 4. 2 times a, and the a is 1, gets us negative 4 over 2, or negative 2. So the vertex is going to be at negative 2 comma something. And to find out what the something is, I just plug in negative 2 for x and get y. So negative 2 squared is 4. 4 times negative 2 is negative 8 plus 5. And this will get you 1. So the vertex is at negative 2 comma 1. So I go over here and plot negative 2 comma 1, which is right here. Now again, the axis of symmetry is going to go through this vertex, and it's going to be a vertical line. And it's going to be vertical because I'm going to draw a U that's opening up. And so that line should show me the symmetry. Now, since it's a vertical line, we think about Vux. And we write the equation of that vertical line, the axis of symmetry, as x equals some number. Well, what does x equal for any point on that line? For this line, x is negative 2. For this point, x is negative 2. For this point, x is negative 2. For this point, x is negative 2. For that point, x is negative 2. So x is always negative 2. So that means the equation of our line is going to be x equals negative 2. And then we need the maximum or the minimum value. Well, it's going to be, since the parabola is opening up, it's going to be a minimum value, and the minimum value is y equals 1. So the minimum value is 1. Okay? All right, so we have a lot of information about this guy. We need to come up with a couple of points so that we know what this U is going to look like. Well, since your vertex is at negative 2 comma 1, I'm going to pick two x values. I'm going to use this table. Two x values to the right. So I'm going to choose negative 1 and 0. Those are my next two x values to the right. I'll plug these two numbers in, these two x's in, to find out what the y's are that go with them. And then I'll have two more points that I can graph. So negative 1 squared plus 4 times negative 1 plus 5. Get you 1 minus 4 plus 5, which is 2. So the y that goes with negative 1 is 2. Now, I like choosing 0 anytime I can, because when I do that, I plug in 0 for x, this term becomes 0, this term becomes 0, and you basically get 0 plus 5, which is just 5. So we have two more points. Negative 1 comma 2 is right here. 0 comma 5 is right here. Now, because this u is symmetrical, I can mirror these on the other side. Put a point here, put a point here, and then draw your u. And that's it. We're done. I'll say that's it. I know that's a bit of a process. Not hard, I don't think. Just takes some time. Okay? All right. Let's try this next one. Okay, this guy. This parabola is going to open up or down? Well, it's going to open down because A, B, C, A is negative. Where's the vertex going to be? Well, the x value of the vertex is going to be opposite B over 2A. The B is 12, so opposite of that is negative 12. 2 times the A is negative 3. So we get negative 12 over negative 6, which is 2. So the x value of the vertex is 2. I'm going to plug that in for the function to see what y is going to be. So I know where the point is. 2 squared is 4. 4 times negative 3 is negative 12. 12 times 2 is 24 minus 7. Negative 12 plus 24 is 12. 12 minus 7 is 5. So the vertex is going to be at 2 comma 5. I'm going to go plot that. 2 comma 5. I go right 2, up 5, and that's my vertex. Now the axis of symmetry is going to go through that. So we draw a dotted line through the vertex, and it's going to be vertical again, because right now the axis of symmetry is always vertical. And the equation is just going to be x equals, because of Vux, x equals. So x is going to be equal to 2, because x is always 2. Now what you should start to find out is that the axis of symmetry equation is always going to be x equals whatever the x is for the vertex. X is 2. Okay? Now, minimum or maximum, I want to make sure we put that in here. Okay? Since this guy opens down, it's going to have a maximum. It's going to have a highest value, a highest point, which is going to be y equals 5. And again, it's always the y coordinate of your vertex. Okay? All right. Now, T-chart this bad boy. Find two more points to put on here. Right? Well, since the vertex is at 2 comma 5, I'm going to choose two x's to the left, because that lets me choose 1, and it lets me choose 0, and I like choosing 0. Right? The math gets really easy. So let's plug in 1 for x. You get negative 3 times 1 squared plus 12 times 1 minus 7. 1 squared is 1 times negative 3 is negative 3 plus 12 minus 7. So this is going to be, what, 2. So the y here is 2. I go back up here. If I plug in 0 for x, these become 0. 0 minus 7 is negative 7. And they're my 2 points. So I go 1 comma 2, 0 comma negative 7 goes all the way down here. And then I mirror that on the other side. And then you draw your u. Boom. Boom. Okay? And that's all there is to it. Again, I know it's a bit of a process. Okay? Try another one. Okay? I'll give you a couple of minutes with this one. Give it a shot. See if you can't figure out what it's going to look like. Start the video back up and see if you're right. All right, did you get this? So the parabola is going to open up. The vertex is at 2, negative 9. The axis of symmetry is x equals 2. The minimum, it's going to open up. So the minimum value is at negative 9. Okay, and that show you a little bit about where the vertex comes from. And you got 2 points here. 2 points on the graph are 1, negative 7 and 0, negative 1. So you want to plot those. And then mirror image, make your U. All right? Right, got a couple more here. I want to walk you through this one because, as you can see, your your B is missing. There's no middle term here. There's no linear term here. What that means is that B has to be equal to, not 1, but 0. Okay, that's really the only trick here. This vertex is going to open down because A is negative. And I'm going to go find the vertex. Going to find the x-coordinate by doing opposite B over 2A. Well, this is just 0, so it really doesn't matter what A is because 0 divided by anything is just 0. So the vertex is going to be at 0, comma. Well, if I plug in 0 for x, this is 0. 0 plus 9 is 9. So we go over and we plot 0, 9. The parabola is going to open down. So the axis of symmetry is just going to be along the y-axis. So the axis of symmetry is going to be x equals 0. Now this is going to have, because it opens down, it's going to have a maximum value, and that maximum value is going to be at 9. Okay? So we have some pretty good ideas of what this thing's going to look like. We just need to pick some points and then draw them out. Because the vertex is on the y-axis, I'm going to choose positive 1 and positive 2 for my x values because I'd rather do positive than negative. And so we plug these in. Y equals negative 3 times 1 squared plus 9. This is going to be negative 3 plus 9, or 6. So this y is 6. Plug in 2. 2 squared is 4 times negative 3 is negative 12 plus 9, which is negative 3. So at 2, this is negative 3. And so we got some more points to plot. 1, 6 is here. 2, negative 3 is all the way down here. And we're going to mirror image these guys. And then make your parabola, make your U. Okay? Make sense? All right? Try 5 and see what you come up with. Did you get this? Okay, it's going to open down. Vertex is at 0, 1. Axis of symmetry is at x equals 0. The maximum value is y equals 1. And then my 2 points, the 2 x's I chose to get my 2 points were 2 and 4. And the reason why I chose that was because I had a fraction for my a. Right. And so if I choose multiples of the denominator, so if I chose multiples of 2, then when I multiplied by that negative 1/2, I would get whole numbers. So I'm going to choose multiples of the denominator if my a is a fraction. Okay? All right. One more for you to try. Try 6. See what you come up with. Stop the video. Start it back up and check. If you're still struggling, then come in and see me during STAR or after school, and we'll work through it. Did you get this? It opens up. Vertex at 0, excuse me, 0, 1. Axis of symmetry at x equals 0. The minimum value is y equals 1. I picked 1 and 2 for my x values. I didn't worry so much about it, what I chose for my x's to get my 2 points, because the a was a whole number, not a fraction. So I didn't have to worry so much about what I chose. So that's what I got. 1, 3, 2, 9 are points on the graph. Mirror image, draw your U, and we're done. Okay? Hopefully it makes enough sense. Try the homework out in Canvas. If you need some more help, come see me.